Hubble tension mystery. A new perspective. One of the biggest puzzles in astronomical physics is that the universe expands faster than theoretical predictions. Nevertheless, researchers at the Bonn and St. University would have discovered the key to solving this constant mystery. Their conclusion shows that the Milky Way can be located in a huge space void in a very empty spatial area. It is interesting that when alternative gravity theory is used, the spacing between the universe's expansion speed and observed speed is allowed. Nevertheless, there is an important warning of this innovative idea, which is directly challenged to the basics of the standard universe model, which has long been part of astronomy. About 100 years ago, for many generations, researchers were convinced that the universe was a difficult structure. Even Albert Einstein also adhered to the idea of the static universe at first, and he regretted later as a youngest in his life, adding permanent cosmology to his equation. Young Belgian priests and astronomical physics George Lima already showed Einstein in 1927. But from looking back, I know that the conclusion of Lima TRE has a decisive advantage. Eventually, they made a prediction that could actually observe, overcoming the gap between the expansion of the universe and the light of the galaxy. If the universe actually expands, other galaxies must be distant from us, just as the balloon's branch swells. In the same way, when the light of this galaxy moves towards us, the wavelength lines and the light is moved with the red end of the spectrum. In the late 1920s, American astronomer Edwin Hubble confirmed this phenomenon by thoroughly observing numerous galaxies at the California Olson Observatory. He discovers that their light is actually a red displacement, providing specific evidence of the expansion of the universe. This discovery also suggests that if the universe is constantly expanding, it would have occurred at a dense time if this process was traced again. This idea now forms the foundation of a great explosion theory. In 1990, astronomers discovered another amazing fact, that the universe was not only expanded, but also accelerated the expansion. Scientists give this acceleration of this dark energy and mysterious force, which is considered to develop space at a constant growth rate against gravity. Hubble's mysterious tension raises fundamental questions about the expansion of the universe. Why does this happen faster than expected? This space puzzle is based on the task of determining the exact expansion speed. In paper, this speed is expressed in constant habits, but in reality, the exact measurement resulted in conflicts known as Hubble's tension. According to the standard model, the Hubble constant must be about 67 kilometers per second per megaparsec. To present this in the future, 1 megaparsec is about 32.6 million light-years and 9.46 trillion kilometers per year. This increases the speed of galaxies far from each other to 32.6 million lungs, which is 67 kilometers per second, which is delivered to mega Sarbol of 244,000 kilometers per hour. Nevertheless, direct astronomical measurements using supernova, gravity lenses, variable stars, or red giants provide a constant Erbla 73 kilometers per second to megaparsec, which is 264,000 kilometers per hour of megaparsecs. How can you explain this quite higher value? Can the previous research affect the measurement error? This problem was considered when the Space Telescope James Webb modified the data from the Hubble Space Telescope. Research groups led by Nobel Physics, the Adam Rice of Johns Hopkins University in Baltimore, have analyzed Webb data for the past 2 years. Compared to the predecessors, given the very excellent Webb function, experts explain this as ensuring the ideas of the high-end universe. As a result, WebBB data has been proposed to confirm the exact confirmation of the Hubble voltage. Today, the most complete Webb dataset, including supernova, variable stars, red giant, and carbon-rich stars, confirmed that the universe does not act as expected. The latest analysis was determined by megaparsec constanta Hubble 72.6 kilometers per second. According to RIS, the gap between predictability and observed expansion speed indicates that our understanding of the universe is incomplete. One opportunity is to lose vision of the unexpected urge of the early universe after the Big Bang. As an alternative, dark energy can be developed. Perhaps today, it is more dense or intense than the previous universe. Nevertheless, scientists also consider alternative explanations outside dark energy. One interesting hypothesis suggests that the Milky Way, including Earth, can be located in a huge space structure known as a boost. To understand this huge emptiness, you must first remember the comprehensive structure of the universe. Stars and planetary systems are found in the galaxy, and as a result, the formation of the galaxy cluster is combined in the superclamer. For a long time, researchers have believed that superclasses are the biggest consistent structure in the universe. Nevertheless, large-scale polls later found that the superclass was later in the network structure, rather than randomly distributed in the space. The grid of this structure is formed of a long fiber known as hundreds of millions of lungs. In the same breath, filaments are also too big and almost no problem. In the same way, the night sky is filled with numerous stars and galaxies, but some researchers suggest that these holes make up most space. About 50% to 90% of the universe represented by drawings are almost independent of large areas. According to a study conducted by Sergei Mio at Bonn University, space voids can contribute directly to the mysterious solutions of space expansion. A study conducted in cooperation with researchers at St Andreas in Scotland. As a result, the surrounding substances are dense, producing gravity that pulls the galaxy into the pore in the edge of the edge. This simple concept means that the galaxy has retreated from us faster than expected. In this context, changes in Hubble constant can be associated with this inadequate dottedness. Simple but important explanation. Nevertheless, there is a fundamental problem. The standard space model does not take into account such voids because it contains uniform distribution of material in the universe. But how can galaxies explain the 600 million lights observed? And can this leave 4 times faster than the standard model allowed? To solve this problem, Pavlos Krupp, which is involved in empty research, argues that the standard model is based on Einstein's gravity theory and can act differently from expected. In particular, the university's research group at Bonn and St. Andreas used gravity theory modified in computer modeling. The modified Newtonian dynamics, MOND, which was proposed by Israeli physicist Mordechai Milger about 40 years ago, remains the theory of outsiders today. Nevertheless, MOND predicts the existence of a huge empty bubble in the universe, which is just an important point. As Milger suggests, gravity works, Hubble's tension problem disappears. Observed deviations come from violation of material distribution, so there will be only ongoing control over the expansion of the universe. Nevertheless, this should also reject the established theory of Newton and Einstein about the nature of gravity. Krupp claims that this is a serious obstacle to research. In particular, he emphasizes the strong effects of established theories that play a decisive role in research finance distribution. Alternative approaches that challenge long ideas are often non-scientific, complicating the financial support of the relevant committees. Regardless of the explanation, Hubble's tension is one of the largest universe mysteries. Our understanding of the universe was probably not completed because new observations continued to challenge ordinary wisdom.